Good afternoon, students. Welcome to the 29th lecture of fluid mechanics. So we are in the unit 3. So in the last class, we are discussing about the topics of Reynolds experiment. So we have conducted an experiment, right, by taking a glass tank, water, and a dye. So we have seen with the different discharges, we have seen three various types of flows. That is a laminar flow, transitional flow, and a turbulent flow. Okay, so today in this class we'll discuss about the characteristics of laminar flow, turbulent flow, and transition flow, and also the applications of Reynolds experiment, the applications of Reynolds number where they are using commercially in the real time, and also the background of pipe flow theory. So what how the various scientists have experimented about the fluids in the pipe, and they have given the various derivations and also the formulas. Right? We'll see these topics in this class. Yes. So we are discussing the characteristics of laminar flow and turbulent flow, and also the applications of Reynolds experiment. Right? So this is as usual till the end of this unit. You can see this type of figure till the end of the unit in all the slides, right? Yes. So in the last class we have discussed about we have done an experiment on the glass tank in order to see the Reynolds experiment, right? So today in this class, we'll see the importance of Reynolds number, Okay, right. So the Reynolds number RE, where we can write RE or it may be R. Okay. Yes, 1 second.
Good morning, students. Welcome to the 32nd lecture of environmental engineering subject.
Yes. The Reynolds number RE is only the dimensionless parameter what we have discussed, right? Next one. The parameter which is always important in the equations of fluid motion. So whenever you are discussing about the various types of fluid motion, this type of dimensionless number is useful in solving the problems. Okay, in solving the problems. The Reynolds number is very small comparatively to unity. The Reynolds number is very small and it is equal to the unity, right? Okay. Extremely small length scales or by dealing with a highly viscous fluid. So viscous fluid means that is such as laminar or turbulent flows. So the Reynolds number is very important in solving the high viscous liquids with the extremely small length scales. Since RE formula is equals to rho UL by mu, the smallness of RE is achieved by considering the small length of the scales with high viscous fluid. Reynolds number by treating the flows of very small velocity, so-called creeping flows. Next. Identification of types of flow is important in manufacturing of dosage forms and also handling the drugs for administration, right? So whenever the type of flow you are using, it is an open flow or a closed flow. So these are used in some manufacturing units for handling of the drugs for administration. The flow of fluid through the pipe, can be viscous in nature or turbulent in nature, and it can be determined by using the Reynolds number. Reynolds number have no unit, so keep in mind whatever the Reynolds equation RE is equals to mu into U into L divided by mu is a dimensionless unit, right? Dimensionless unit. Next, the significance of Reynolds number. Significance of Reynolds number. So the definition of Reynolds number is given by RE to the length is equals to rho into V into L divided by mu. Okay. Now, the Reynolds number can be interpreted as the ratio of inertial forces to the viscous fluid. The ratio of inertial forces to the viscous effects. Right? At low Reynolds number, what happens? The viscous effect is comparable to inertial effect. The viscous effect is comparable to the inertial effect. Flow behaves in the order of laminar flow. So, low Reynolds number napudu, the laminar flow will be, the flow of fluid will be in a laminar type. Whenever the Reynolds number are high, viscous effect is insignificant compared to the inertial effect. Thereby, the flow pattern is irregular, therefore unsteady and random in situation. Thereby, the type of flow will be turbulent. The type of flow will be turbulent. The type of flow will be. So, you are having different types of turbulent flows whenever the Reynolds number is high, right? Thereby, the flow pattern will be irregular in shape, unsteady and random in nature. Understood? Right. Then applications of Reynolds number. Next one is the applications of Reynolds number. A Reynolds number is used to predict the nature of the flow, right? So whenever you are getting any natural calamities or any rainy season, so in order to study the nature of the flow, in order to study the flow of fluid, in order to study the flow of air in the nature, the Reynolds number is applied in such cases, right? The Reynolds number are applied in such cases. Second, Stokes law equation is modified to include Reynolds number to study the rate of sedimentation in the suspension. So whatever the Stokes law, what we are derived in the earlier class, unit 2, so it has been included in the Reynolds study in order to see the sedimentation in the suspension. When the velocity is plotted against the distance from the wall, flowing, the conclusions can be drawn as. So what are the conclusions? So whenever the velocity is plotted with respect to the distance, the flow of fluid in the middle of the pipe, is faster than the flow near to the wall. So what are the conclusions drawn with respect to velocity against the distance is whenever the fluid is flowing in a pipe at some velocity. So whenever the fluid is coming at the middle of the pipe, the velocity is faster than the nearer to the wall. The velocity is faster than the fluid near to the wall. Next, second one. At the actual surface of the pipe, the velocity of the fluid is 0. So actually, at the surface of the wall pipe, so at the surface of the pipe and wall, so pipe ki wall ki surface the velocity of the fluid is 0. Whenever you are plotting a graph between the velocity versus distance, right? Next one. Applications of Reynolds number. The Reynolds number is usually to identify the type of flow likely to occur in the process. Means it is mainly used for study of the flows, the type of flows, right? So mainly these are used to study the laminar flow, use it to study the turbulent flow, and also use it to study the transition flow. So the laminar flow, so this is the pipe wall. So when circular pipe cross section chuste, so whenever the arrow marks are going in a straight line fashion, these are nothing but a laminar flow. So whenever the pipeline, whenever the arrow marks are coming closer together and coming distance and making the flow in some sort of indefinite shape, that is nothing but the transition flow. So whenever the fluid particles or molecules are moving in a zigzag fashion see the arrow marks, then this type of flow is nothing but a turbulent flow. Got it? It's nothing but turbulent flow. Okay, na? So coming to the Reynolds number, where we are applying for pipe flow as well as the open channel flow. See here, for the pipe flow, the Reynolds number for the pipe flow, NR is equals to VD divided by V. VD divided by the viscosity. where V is equals to mean velocity, V is equals to diameter of the pipe, V is equals to kinetic viscosity of the fluid. Thereby, for a pipe flow, Reynolds number. So, man ikkada NR అని పెట్టుకున్నాడు. In some books, it may be written as RE also. Don't get confused. RE is less than 2000. It is a laminar flow. When RE is greater than 4000, it is a turbulent flow. So, it is in the case of pipe flow. Okay, pipe flow. Next, the Reynolds number in case of channel flow, NR, that is R is equals to V into R by viscosity, whereas R is equals to hydraulic radius. In the open channel, we are calling them as not a diameter of the pipe. Why? Because it is not a closed one. So here it is open conduct, where we are calling them as a hydraulic radius R. Therefore, for a channel flow, NR less than 500 is a laminar flow, and NR greater than 2000 is turbulent flow. అర్థమైంది కదా? సో ఇక్కడ ఎన్ఆర్ లెస్ దెన్ 2000 లామినార్ ఫ్లో, ఇక్కడ ఎన్ఆర్ గ్రేటర్ దెన్ 2000 అంటే టర్బులెంట్ ఫ్లో. సో హియర్ ఇట్ ఈస్ రెడ్యూస్డ్ ద నెంబర్. వై? బికాస్ ద అప్లికేషన్ వాట్ వీఆర్ యూజింగ్, హియర్ వీఆర్ యూజింగ్ ద పైప్ ఫ్లో, హియర్ వీఆర్ యూజింగ్ ద ఓపెన్ ఫ్లో, రైట్? నెక్స్ట్ where we are using the types of flows. So the okay, there are two types of flows. Whenever you are coming across the external system, the pipes or open ducts. The first one is the internal flow. Second one is the external flow. So internal flow ante ekkada jarugutundi? Generally, as per the before slide, the internal flow is at the flow in the pipes. External flow is flow over the bodies or open ducts, drag, lift, etc. will be covered in the other things. Okay, will be covered in the other things. So generally we will discuss internal flow type of study. Okay, so the examples of the internal flow are water flow in the pipes. The examples are water flow in the pipe, and also the blood flow in the veins. Human body lo or animals, the blood flow in the veins. Coming to the oil and gas industry. So మనం ముందు చూసుకున్న oil refinery, steel plant చూసారు కదా, that is an example of oil and gas industry. Next, cooling systems of a car. So car, vehicles, lorries, buses locally we are having a radiator where the hot water, cool water is moving upper layer, middle layer, lower layer, and going to the internal chambers of the engine and coming to the radiator. This is also one type of flows, which is internal flow. Next, air conditioning, chilled water system, right? Air conditioning systems, how the water is moving inside the pipe flows. So these are the real-time general examples where these are used for the application of internal flow mechanism. So this unit is totally discussed with the internal flow mechanism. So we will discuss the flow of fluid in the pipes. Okay. Yes. Next, flow of fluid through the pipes. Next heading is a flow of fluid through the pipes. So the characteristics of flow through pipes. So we will discuss the characteristics of the flow through pipes, that is laminar characteristic, transitional characteristic, and turbulent characteristic. Next, energy losses in the flow through the pipes. Energy loss or head losses in the flow through the pipes. So energy loss may be the minor losses or major losses. Next, major losses such as loss of head due to the friction can be said by Darcy-Weisbach formula. So we are having this derivation in the next coming classes. That is, the major loss of head is due to the friction is said by Darcy-Weisbach formula. And the minor losses such as loss of head at the entry level. So minor losses, loss of head at the entry level, the change in the diameter, bend of the pipe, etc. Right? The problems on the head losses we will discuss. Next thing we'll discuss is a hydraulic gradient line. So we'll discuss about the hydraulic gradient line. We are calling them as HGL, and total energy line, that is TEL. Hydraulic gradient line and hydraulic gradient line HGL, and total energy line TEL. So these questions will get in a part A, small answer questions. Define the terms minor losses, major losses, HGL and TEL అనే question రావచ్చు. Next, effect of entry at the pipe. So whenever the fluid is entering at the pipe, what will be the effect at the entry of the pipe? And when the change in the diameter occurs, what is the changes we can see? And also bend on hydraulic gradient line and also total energy line. Next, plotting of HGL and TEL. Design of pipeline for a given flow using the formulas and using the nomograms. Computation of height of reservoir, compounded vial and equivalent sizes. So in the flow through the pipes, it may be generally in the closure conducts. So what are the things we will discuss? These things we will discuss in this unit 3. What are the major losses? What are the minor losses? What are the other scientists given the derivations based upon the major losses and the minor losses. Next one. What is a laminar flow? So I already mentioned, whenever you are having a medium discharge with medium velocity of fluid in a glass tube in the Reynolds experiment, whenever it is flowing in a straight line fashion with a low discharge, then it is nothing but a laminar pipe phenomenon. Then coming to the applications of laminar flow, where we are using this laminar flow commercially, right? The first one is aeronautics industry. So this type of application can be seen in aeronautics industry, air fuel usage of planes, where we are using air fuel usage. We are using air fuel usage. Second one, semiconductor industry. The second application is semiconductor industry in thermal based mass flow controllers. Ekkada use chestam semiconductor industries lo at the thermal based mass flow controllers. There you are using this type of laminar flow applications. Next one is pharmaceutical industry, unidirectional flow in the laminar. So we can see the unidirectional flow in the laminar. Next. So we got some clear idea about what is the meaning of laminar flow and what is the meaning of the transition flow and what is the meaning of the turbulent flow. Then we'll see the differences between the laminar flow and turbulent flow. So you may get this type of question in the essay type, or it may be in the 2 marks. Differentiate between laminar and turbulent. So the laminar flows are characterized by low velocities. So generally ga maniki low velocities lo fluid anedi pipe lo nunchi veltunte, so generally we occur laminar flows. Okay, next, whenever the fluid velocity is high flowing in a glass pipe, we are getting turbulent flows. Small length scales. So in order to get a laminar flow, or in order to use a laminar flow type of application, we have to go with the small length of pipe scales. So మనకు small length pipe scales ఉన్నాయి. Here we are using large length scales for obtaining the turbulent flows. Okay, next, high kinematic viscosity. So we are getting high kinematic viscosities in case of laminar flow, whereas here we are getting low kinematic viscosities of fluid in the turbulent flows. Next, Reynolds number is less than the critical Reynolds number. Reynolds number is less than the critical Reynolds number. Here the Reynolds number is greater than the critical Reynolds number. So the Reynolds number, R for Reynolds, N for number. NR అని ఉంటుంది. Whenever you are conducting an experiment, it can be written as Reynolds experiment, RE అని ఉంటుంది, right? So whenever Reynolds number is less than the critical Reynolds number, we are calling them as it falls under laminar flow. Whenever the critical E is greater, whenever the Reynolds number is greater than the critical Reynolds number, it falls under the category of turbulent flow. Next, viscous forces are dominant. So here the viscous forces are dominant. Here inertial forces are dominant. So turbulent cases lo inertia forces అనేది dominance ఎక్కువ చూపిస్తుంది, dominating. And in the case of laminar flow, viscous forces are dominating, right? So these are the main fundamental differences between the laminar flow and turbulent flow. Now we'll see the various characteristics of the flow types. The first one is laminar flow. The first one is a laminar flow. So in the laminar flow, the Reynolds number is less than 2000. So we are considering in the laminar flow, it is less than 2000. Second one, it is of low velocity. We have to maintain low velocities. Next, dye does not mix with the water. Whenever the velocity is very at low discharge, whenever it is flowing at very, very less velocity with a less Reynolds number, so the dye, whatever the experiment you are doing, the dye does not mix with the water. Next, the fluid particles move in a straight line fashion. Obviously, the fluid particles, whatever the present in the dye, they are moving in a straight line fashion along with the water. Next, simple mathematical analysis can be possible. So here, whenever you are doing an experiment or doing any analysis, simple mathematical analysis can be done very easily. Next, rare in practical water systems. So generally, మనం ఈ applications ముందు చెప్పుకున్న slides లో, so real time applications లో we cannot see the laminar flow generally. Only for specific applications we can see this type of real time water applications, right? Next one is transition flow. The transition flow lies between Reynolds number of 2000 and 4000. So these are lying in between the number 2000 and 4000. Next, medium velocities. So manaki ikkada velocities ala untayi. The velocities are generally in medium velocities. Next one, the filament oscillates and mixes slightly. So in this case, what happens due to the turbulent flow, due to the high velocities, whatever the filament, whatever the dye we are using, it will oscillate due to the high discharge and mixes with the water. This type of phenomena is nothing but transitional flow. Here it is oscillating and mixes slightly when compared to the laminar flow. Therefore, we are getting transition type of flow. Next, third one, turbulent flow. A turbulent flow where the Reynolds number is greater than 4000. Here we are getting high discharges with high velocity. The dye mixes rapidly and completely. Okay, na? Here dye is mixing, whatever the dye we are shown in the experiment in the last class. So here the dye is mixing very, very rapidly and completely. Here the practical paths completely irregular. So whatever to the original path coming from the laminar, so laminar lo nunchi melliga it is converting into transition nunchi it is converting into turbulent, where it mixes rapidly and completely filled with the water. The particle parts completely irregular in shape. Next, average motion is the direction of the flow. Okay, na? Average motion is in the direction of the flow. Next, mathematical analysis doing for this work will be difficult. Experimental measures are used. So theoretically, we cannot solve this type of turbulent flows. Only experimental process can be done in the turbulent flows. This is the most common type of flow, generally occurs in the nature applications. So naturally, manaki convective applications flow, most commonly type of flow what we are observing in the day-to-day life is turbulent flow. So understood the characteristics of the laminar flow, transition flow, and the turbulent. So by knowing this concept, so whenever you are solving the problems, you have to check whether it is a laminar, turbulent, and this transitional depends upon the characteristics and experience, right? The next topic is loss of fluid friction. Next one is the loss of fluid friction. So generally friction is of many types. Friction can be of many types, but we are discussing the fluid mechanics, not the soil mechanics. So in this fluid mechanics, generally we are using only one type of friction, that is fluid friction. Then what is the meaning of friction here? The term friction is the force resisting the relative motion of solid surfaces, fluid layers, and materials elements sliding against each other, right? So ఈ ఫ్రిక్షన్ జరిగిన తర్వాత ఏం జరుగుతుందంటే ఆటోమేటిక్గా స్ట్రెస్ అనేది ఫామ్ అవుతుంది whenever the friction is getting reduced, right? So here the force resisting the relative motion of the two solid surfaces, either it may be tires on the roads, right? Next, fluid layers means crude oil on the top surface of the ocean water. Okay, materials elements sliding against each other. Materials elements ante if you take a bearing, so bearing ki mana emuntundi, we are having a outer racer, we are having a inner racer. The outer racing ki inner racing ki madhyalo you are having a balls, you are having a steel balls. So with the steel balls, what you are doing, this is some sort of friction, ball bearing friction. So whenever you are looking this type of friction, the inner race is moving through the inner circle is moving in one direction, whereas the outer surface is moving in other direction or in same direction. So here what happens, ఇది ఒక మెటీరియల్, ఇది ఒక డివైస్ ఆర్ ఇది ఒక ఎలిమెంట్ అనుకుంటే దీని లోపల మెటీరియల్స్ ఆఫ్ ద ఎలిమెంట్ అంటే ఏంటి, మెటీరియల్ లో ఉండే చిన్న చిన్న పార్ట్స్ whenever they are sliding to each other, then also we will call that one as a friction. Understood? Now there are various types of friction to discuss, but to the main concern we will discuss only about the fluid friction and loss of fluid friction. Now see the first one. First one is the dry friction. The dry friction resists relative lateral motion of two surfaces in contact. Okay, so the relative lateral motion resists the relative motion of the two solid surfaces which are in contact. The dry friction is subdivided into static friction between non-moving surfaces and kinetic friction between the moving surfaces. So dry friction again it is divided into two parts based upon the surface in contact. First one is the non-movable surfaces. First one is the static surfaces, which is also called as non-moving surfaces. For example, a big machinery, మీ ల్యాబ్ లోపల ఒక బిగ్ మెషిన్ ఉంది, or in computer lab, or in a engineering lab, or in a mechanics lab, manufacturing lab, you are having a big lathe machine which is mounted on the earth, mounted on the ground. So it is mounted on the ground, but it is not fastened, it is not cemented, nothing, just దాని మీద ఉంచోబెట్టారు. Now that type is nothing but a dry friction. So it is static friction where there is no motion for some part, some abstracts when compared to the human being. Next. So whenever the surfaces are in kinetic friction between the moving surfaces, so when we call the kinetic friction can be called as whenever the surfaces are in moving surfaces, right? For example, belt and rollers. So మనకి ఇది బెల్ట్ అనుకుంటే, సో దిస్ ఇస్ అ బెల్ట్. ఈ బెల్ట్ కి మనకి ఇక్కడ ఒక రోలర్, బెల్ట్ కన్వేయర్స్ చూసే ఉంటారు కదా, ఇక్కడ ఒక రోలర్ ఉంటుంది. సో దిస్ రోలర్స్ ఆర్ రొటేటెడ్, దేర్ బై ద బెల్ట్ ఇస్ ఆల్సో రొటేటింగ్. దేర్ బై ఏం జరిగింది, దీనికి అనుసంధానం జరిగి దీస్ టూ థింగ్స్ ఆర్ మూవబుల్, then we are getting the kinetic friction. So these are the two categories which are in the dry friction. Second one, fluid friction. Okay, the fluid friction. Second one is a fluid friction. The fluid friction describes the friction between the layers of the viscous fluid that are moving relative to each other. For example, if you take a glass of water, right? So whenever it is in motion or whenever it is in movement, so you can see the fluid friction acting in the closed bottle. So the friction between the layers of the viscous fluid is nothing but the fluid friction, right? Yes. The third one is lubricating friction. Third one is a lubricated friction. It is also a case of fluid friction where the lubricant fluid separates the two surfaces. For example, if you see in an engine of an automobile or engine, so you are having number of components like a correcting rod, crankshaft. So thereby what happens, the crankshaft and the wall of the cylinder, wall of the engine, these two are separated with the help of the lubrication. So ఇక్కడ ఏం చెప్తున్నారు, a thick fluid film such as lubrication is placed between the two surfaces, and making separation. కానీ ఆ రెండిటికి you have a connection, but it should be connected with the means of lubrication, which is also a fluid friction. Next, skin friction. Next one is a skin friction. It's a component of drag. The force resisting the motion of the fluid across the surface of the body. Right? The skin friction is a component of a drag, the force resisting the motion of the fluid across the surface of the body. Next, internal friction. It is also the force resisting the motion between the elements making up a solid material where it undergoes a deformation. So whenever the solid material is undergoing a deformation, so before undergoing a deformation, it goes some sort of internal deformation. It goes under some form of internal information. Then only the then only it undergoes a deformation, right? Next one. So these are the various types of friction. First one is dry friction. Second one is fluid friction. Third one is lubricating friction. Fourth one is a Nerukudi friction. Another dry friction, fluid friction, lubrication friction, skin friction, and internal friction. So we are not having all the types of friction to study because we are in the fluid type of mechanism. So we will use only fluid friction or your lubricant friction process. Okay. Yes. Then coming to the laws of fluid friction. The fluid friction is a friction that occurs when the objects move across or through the fluid. So fluid friction ఎలా డిఫైన్ చేస్తున్నామంటే, it is a friction that occurs when the objects are moving through the fluid. So ఒక fluid, రెండు ఆబ్జెక్ట్స్ కానీ మూడు ఆబ్జెక్ట్స్ కానీ దాని మధ్యలో ఫ్లూయిడ్ అనే లేయర్ పాస్ అవుతున్నప్పుడు ఫ్లూయిడ్ ఫ్రిక్షన్ అనే కాన్సెప్ట్ బయటకు వస్తుంది. Now if you see the example, see this figure, what happens here, the person is swimming, the person is resisting with the water and is swimming towards the water. So it is a swimming pool, that is no problem. So whenever it is in a flowing river, whenever the person has to swim opposite to the flowing river, it will be very, very difficult to flow. So being a swimming pool, it is very, very easy for a person to swim without any problem. Now, if you see the examples, the swimmer's body and the surface of water. So, here automatically we can see the fluid friction between the swimmer's body and the your water boundary. Next, greasing a squeaky door hinge. Now, the two hinge parts are sliding across the fluid, right? Next one, greasing a squeaker door hinge. Now the two hinge parts are sliding across the fluid. There is also one type of example. Next, air resistance is an example of fluid friction caused by the particles that make up air. It causes falling object to slow down. So if you see the air as a medium, air also comes under the topics of fluid mechanics, where air resistance is an example. See here how the person is gliding in the parachute. So it doesn't have any motor mechanism, only through the air friction, this air resistance can be capable of bringing or moving up or sailing in the sky. Next, throwing a frisbee is slowed down by the air resistance. Just like a frisbee, just like manaki, what do you call the discus throw, in the same way, throwing a frisbee also makes the air resistance. So air ni pierce cheskuntu manaki it is giving the action. Next one is skydiving. Next one is the application is skydiving. Parachute is most slightly slowed down by the air resistance, right? In the skydiving, a parachute is slowed down by the air resistance. So like this, the fluid friction, whereas in the fluid or in the air, we can use n number of examples for this type of fluid friction properties. Yes, the fluid friction is usually less than the sliding friction. Okay, the sliding friction is also one type of friction where we can use or we cannot use some sort of applications there. So when you compare with the sliding friction, the fluid friction is always usually less than that of the sliding friction. Next, lubricants change sliding friction to the fluid friction. So whenever you are adding lubricant to any object, this lubricants can change sliding friction in municipal facilities it is converting. So the lubricants can change the sliding friction to the fluid friction. Next, the lubricants are slippery in nature. Whatever the lubricants you are using for automobiles or any other applications, any other mechanical members, generally it is having a high viscous nature. That's why these are slippery substances. Next, grease is also a semi-solid lubricant where these are used for the motor cars, cycles, scooters, etc., which are highly viscous and solid in nature. Cooking oil also serves as a food material, so the food won't stick at the bottom of the pan. So whenever you are making a dosa on a pan, so definitely you have to apply the oil. So without oil also we can do by using low flame. Generally for a dosa making or any rice preparation, cooking oil is also acting as a friction fluid between the dosa or maybe the rice grain to grain. Next, wax on bottom of surfboard to make it move faster through water. So surfing చేసేటప్పుడు you're having a big board. So దాని మీద ఒక మనిషి నించొని సో దానికి ఒక స్టిక్ లాగా ఏదో ఉంటుంది, లేదంటే స్టిక్ ఒక మనిషి it will stand on the surfing board and he will tag with the steamer ఉంటుంది. So here what the person is doing, the person is tying this to the boat and he is surfing with the plates. So the wax is placed on the bottom of the surfboard in order to make move faster through the piercing water. So these are the examples of fluid friction. Got it? The laws of fluid friction. So the time is 40, 50. Okay, the time is up. So we will discuss the balance theory, balance part in the next coming classes. So till now we have discussed about the various characteristics of the laminar flow, turbulent flow, and transition flow, and also the applications of Reynolds number, importance of Reynolds number, and also the flow of fluid in the pipes, and also the differences between the laminar flow versus turbulent flow. Right? We'll discuss the topic in the next class. Right? Yes. Okay, we'll stop here. We'll continue the class in the next lecture. Thanks for listening the video. And this video will be uploaded in the YouTube. Once the link is uploaded in the YouTube, I will forward the link to your WhatsApp group. So open it, watch it, and like it, and also share it to the students, those who are not coming regularly to the June class. Right? So thanks for watching the class.